Hi and welcome back to video number 3. Now, before going on to different types of evidence, I just wanted to delve a little bit deeper into the different types of fossils that we have and how they form. So come with me and we'll discuss that a little bit more. Now, fossils have been really helpful in telling us a lot about the organism that lived. Despite not being around at that time, we can often tell from the imprint that a dinosaur may have left information about how tall he was, how big, how heavy he was, and so forth. So scientists are really using that information to put together a whole picture of an organism that we never had a chance to see. So there are different types of fossils that we can use to put together that big picture. The first one is our body fossils. As that name suggests, they're of that organism's body. Trace fossils, so they're just traces of. So I mentioned in the last video mold and casts, and there's even things called chemofossils. Now, our fossils are identified based on what they contain in them. So obviously our body fossils are the preserved remains of a part of a body or even the whole organism if the scientists get lucky. So in the picture here to the right, you can see a picture of a bone or a part of an organism's bone there. But in the second picture down there, you can see some footprints or tracks that may have been left behind, and they're called trace fossils. So they might be indicative of their activity that they may have had. They may have been walking across this part of the rock face. They may have been, it might be a burrow that may have been left behind, indicating that that organism once burrowed for shelter and so forth. And then we have other types of fossils called chemofossils, and they're preserved things that may have been produced by an organism. So coal, for example. So looking here, I'll move me out of the way. We've mentioned already casts and molds. So they actually don't contain any of the original evidence, but they take the shape of the evidence that was once buried there. So if ever you, in your younger crafting childhood days, ever made those plaster molds where you may have mixed up the plaster, popped it into a mold, plucked it out, and then you got a chance to paint it. That's the type of thing that we're talking about here. So the mold might be the latex container. You may have even done that in Year 9 making a fossil where we had a latex container. We mixed up some plaster of Paris and we popped it into our mold. We leave it there to set and then we pop it out and it's there ready for us to paint or to look at. And that is then called a cast. And that's a replica of the organism that once was. So what might happen is we might get an imprint that might be left in the rock. And that looks like the organism that once lived there or decayed there. So what's happened is it may have left a footprint, and then the cast happens when that imprint is filled in. So often minerals might seep into that rock and then leave behind a replica or a sculpture of what was previously there once before. So once it's been preserved and discovered, then our scientists can look at that and determine what era it lived in, how old it was, how it behaved, and so forth. Now, when we do this, and I'll move me over there, sorry about all this jumping around, and we can date those organisms, and there's two different types of dating that we can use, and that's absolute dating, and then there is also relative dating. So absolute, as the name implies, is actually looking at the actual age of the rock, and we do that by our radioactive dating methods that we have, so carbon dating and so forth. You would have in your Year 9 course looked at radioactive isotopes that have a half-life and break down by half every however long their half-life is, every 1,000,000 years or 2,000,000 years or whatever. And by determining how much is left of that radioactive isotope is a way of them determining how old that actual fossil that they have found is. But the other way that we can use to date organisms is not in an absolute fashion where we know the actual age of the organism, but more so putting it into a timeline, I suppose, where our younger organisms are found at the top of the rock layer and our older organisms are found at the bottom. And this is called the law of superposition. So this law of superposition is what we use to relatively date our evidence, to date our organisms there. So some organisms are going to fossilize more than others, so we will have that incomplete timeline there, but we have enough evidence there to support those changes over time. So now we'll go on with our other pieces of evidence in our next video.